Hey guys, welcome back to the channel. Welcome back to part 2 of our 1958 Harvard. We got a whole bunch of tweed amps come in waves. Let's surf. So real quick, part 1 we checked out the amp and we gave the client the estimate, and now we're going to service it in part 2, and she approved the entire job. So we're going to do the full Monty on this, bring it back to its former 50s glory. It's Sunday night. We'll do a little work today, but most of this we'll do tomorrow. Had a long day. My old man came into town, my stepmom and stepsister. We got some food, went down to the waterfront. Funny thing about this old Harvard is that my dad is just slightly younger than this 58 Harvard. Just riddle me this, Batman. Why do old amps sound so good? Well, one word you want to keep in mind is the word simplicity. First thing I want to do, it's going to be easier to work on the amp if we take off the AC cable. This old 2-prong is going to be replaced with a safety 3-prong cable so that we have a ground. Going to grab our soft touch pliers or our strain relief puller here. This is a great handy tool, and we're going to pull this out. While we're here, why don't we clean the pots? We got our deoxit here, green label. Work the pot really good. This yellow baddie right here is the death cap that's gonna go. One thing you want to check when you're working on amps are your grounds, your chassis grounds. Make sure that they're in there good. These can pop off. Let's cut out the electrolytic capacitors. We're going to reuse the cardboard. I'll explain that in a second. Sometimes it's easier just to cut them out and desolder the leads individually. Sorry, I got a tripod in my face here. Okay, you can see the bulging. This is a sign that this is going to go. I mean, these are past due. You want to change them anyway, but you can see that's clearly bulging right here. All right, it's Monday, and I'm moving a little bit quick. I got started ahead of time off camera. I got a lot of people wanting to get their amp back, so I got to move kind of quick. So what did I do? I removed the electrolytic caps. I removed the old cardboard, and I stuffed new capacitors inside, new F&Ts. I have a couple videos where I show that process. There's a Champ and a 5E3 Deluxe, so check that out. I'm not going to go through it here. I like to do that sometimes, especially on an amp that's been in one family. Some techs kind of scoff at that and think it's kind of silly. Look, this is a very high value amp. It's been in one family. It is nice to open up the back and have it look original. I do like to see that. You know, do I do it all the time? No, but I think in this case it warrants 3 minutes of time to remove the old cardboard and stuff a new capacitor in. A couple other things I want to do right now is to show you some quick tech tips. You know, I removed the death cap, but the ground lug here, we're not going to reuse. The ground lug on the power transformer, I'm not going to reuse because I'm going to hard solder the ground to the chassis, and I'll show you that. But it's important to always make sure that your transformer, power transformer, is in nice and tight. Also, we're going to want to clean the tube sockets with a little bit deoxit. And I have a special tool that I go through that I made myself to kind of retension all the sockets. And then this is our speaker output jack, this RCA. And I always clean it really well with a razor, because if that gets funky, the amp can cut out and you can also damage your output transformer. So I'm going to do that now. All right, I'm also checking the carbon comp resistors. These can drift. So far, everything's on the money. Now I'm replacing these old leaky yellow Astrons with some new Jupiters. I do like the yellow Jupiters. I feel like they sound very close to the original capacitor. I like the red label ones too, but they're a little bit dark. There's a lot of options now for replacing capacitors that there wasn't when I started as an amp tech a million years ago. You know, working on 50s Fenders is like working on 50s Chevys. What would a 50s Ampeg be like working on? Mercury? So it is time to replace the output transformer. In the first video, we troubleshoot it to the end and we see that the output transformer is bad. And on the end of this video here, I am going to do a circuit analysis and we're going to talk a little bit more about the output transformer and how it went bad. And so if you haven't watched part one, it might make sense to go back and watch it. So what I've decided to do here with the customer is to put in a sour sound output transformer. This is a paper bobbin transformer like the original. It's a very good sounding transformer at a very good price. I've used a few and I'm very happy with these. They sound incredible. And I think that's the route to go on. Why not rewrapping? Well, it can be rewrapped at any point. We're going to give the original back to the customer and it can get rewrapped. Why not now? Well, a couple reasons. One, expense. And I didn't really want to have a huge bill for the client. She is going to sell the amp and the amp is going to be for sale. So we're going to have a great sounding output transformer in it and the amp's going to come with the original that somebody could rewrap and simply put it in, no big deal. If you're interested in this amp, hit me up via my website. Don't DM me, don't make comments, but I ask no tire kickers. Look up what these are worth. Serious people, please. Don't waste her time, my time with, I'll give you $500, okay? All right, got the new OT all in here, and now it is time to put on a new 3-prong power cable for modern safety standards. We get the big iron here, Mr. Marty Robbins. First thing I want to do is I want to scribe it a little bit, right? This way the solder is going to take better to the chassis. I pre-tin the ground and we are going to secure it right about here. Okay, next we're going to carefully heat up the chassis really well. Apply some solder. Good. I like to get a lot of solder on there and I pre-tin the wire. Makes the whole job a little bit easier. You guys know the Marty Robbins song, Big Iron, 1959? Harley spoke to folks around him, didn't have much to say. Big iron on his hip. All right, perfect. This is going to be easy. Okay, and in we go. Nice. All right, so tomorrow, what are we gonna do? I'm gonna burn it in, I'm gonna check it, I'm gonna look for noise, like carbon comp resistor noise, make sure I didn't miss anything. But let's power it up now for the first time and just get a baseline how we're doing. I'm sure it's gonna be fine. And I really wanna hear it, I wanna play through it. And then at the end of the video, we'll do a little circuit analysis. All right, we're engaged. Let's see here. Looking good. Beautiful. Let's check for noise. Gonna need to clean that again. Where is this noise coming from? Here we go. Jack issues. This is a shorting jack, and this is our ground connection here. If this opens up, you're going to hear noise. Get a little deoxit in the middle there. I also like to just mechanically bend it a little bit. Then one last trick. Take a piece of paper, deoxit, red label, soak it, put it in between the shorting jack and the main arm here, and then we're going to close this, right? And we're going to have tension, and we're just going to pull it through. Again. Okay, so we're on a dummy load. Took care of that noise issue. Bring it up slow. Nice, beautiful sine wave. See that? That's not what we were getting before. There it's clipping, and we're just going to slam it. There's your heavy distortion right there. And 10.8. I'm not going to take it any higher than that. That's 10.8 AC volts across an 8 ohm load. That's not our wattage, so we can do 10.8 times 10.8 divided by 8 ohms is 14.5 watts max. That's exactly right. 14 watts. There you go. Also, I want to mention that I sprayed about half a can of this polyurethane on the asbestos, taped it off, sprayed over the asbestos so we're sealed up good. Just made it up. So we just serviced this Harvard 5F10, but let's get something out of the way. There are two Harvards. The 5F10 is the more common one and the better sounding one in my opinion. But I always see, weirdly, the rarer one, the 6G10. And the 6G10, it's a completely different circuit. And you know what it kind of reminds me of? Exactly. The Princeton 5F2. The Princeton 5F2 and the Harvard 6G10 are the same circuit. I guess Fender had some leftover chassis and then they were making the last Harvards with Princetons. I'm not exactly sure. I think all that information's out there though. So the Princeton 5F10 is basically a Champ 5F1 but with a tone control. Simplicity, guys. Simplicity. And the Harvard 5F10 is very similar to the Vibrolux 5F11. So let's do our circuit analysis of the 5F10. And if you watched video 1, this might make a little more sense because we go over a little bit in video 1. But here we have our 6AT6 triode. Don't usually see that in a lot of radios. A lot of CB radios have that. We don't really see that in guitar amps much. We have our 3 inputs. We have our single triode, our volume, our tone. We have a gain stage, and then a phase inverter, feedback resistor, rectifier. Now, this is also very similar to the 5E3 Deluxe. But here's the thing, the 5E3 Deluxe is cathode biased, and the Harvard is fixed bias. We have a diode here, and this is our bias circuit, which gives us negative voltage, right? Ground the cathodes, negative voltage to the grid. Now, the failure on this output transformer, I drew a line here, right? This is a Sharpie, was a short between center tap and plate. It wasn't a short to ground, because if this shorted to ground, what would happen? We'd pull excessive current on the rectifier, and we blow the fuse. So we just have a short between the center tap in here, a dead short. So we had high voltage, but we didn't have any audio getting into this transformer here, right? It's sort of just like a dud. We didn't have the other output tube because this is out of phase, right? Phase inverter. These are 180 degrees out of phase. So this tube was basically not doing anything. So that's why it sounded weak and overly distorted. Now with the proper transformer, we are working great. The Vibrolux is basically the Harvard, except we have vibrato. And this 12AX7 here, we have our oscillator circuit, and what we are doing is controlling the bias. Negative bias comes up here to our depth. This is our oscillator, and then we're manipulating the negative voltage here for our power tube. So Vibrolux, great amp. Harvard, great amp. Princeton, great amp. 6G10, great amp. And Champ. So back in 1958, here's your options. Your little guy was the Champ. The Princeton, these had 8-inch speakers. The Harvard with a 10. And then above that was the 5E3 Deluxe with a 12-inch speaker.